No.
Yes.
Are you doing that today or tomorrow?
I'll do it tomorrow.
Tomorrow.
No matter.
So, Chana, haven't got your presentation in your file folder yet. Would you copy it there?
What room is the presentations in?
DA 601.
Okay. Is that a lecture folder?
No, that's a computer lab.
Okay. Thank you.
I've actually added this stuff to the PowerPoint, so I just plug it into my HTML.
I copy. You update it?
Yeah. I didn't do it.
Where is it? That's
Yeah.
where is it? Is that different with this one?
It's the same, but that's like the not finished.
What do you want me to do? You have an updated one?
Yeah.
Give it to me. How you do it?
Yeah. I'll upload it now.
Yeah, upload it now. I can take it from here. So yeah. Hi Daniel. Nice to see you. So John, let me know when that is finished, okay? You are uploading your presentation on the Canvas file folder, is it?
Yeah.
Group folder, yeah, file folder.
Yeah.
Thank you. There. Is it already there?
Yeah.
Just leave me a second, I'll do it.
Like organization.
So you might want to delete the old one and replace this one instead, okay?
Yeah. I mean, I've written named it, so it's uploaded now. Fine.
It is there.
Yeah.
That was group
11.
11.
I just like to get that. Yeah. Is there a drink tap here?
Sorry?
Is there a drink tap close by?
So, look here. Is this empty or what?
It's
It is. Okay.
RTS. I think honestly, oh no, we have added something.
This is the old one or is the new one?
I think that's the old one.
How come? I downloaded it again.
Or I could actually even like I just get share the file. Then you could
So this is the one I got. This is 10 megabytes, 10.5.
Yeah.
That's a new
Yeah,
one.
finals, yeah.
Which one is the last one? The final. The final.
Yeah. Finals one I just did.
Okay. So let me download that. Yeah.
Yeah, I think I did also I used to send it was I think you see I think you are able to access it quickly on yeah that one so
All right. Just let's make sure this is the one you want to present. All right. I'll go through this quickly. Just have a look. Yeah, this one has everything.
Yeah.
Very good. And this, you know how to play. Yep. All right, great. All right. So we've got 3 minutes to start, but don't rush. I mean, just do on Sultana, plenty of time. And let me check Sultana's presentation also. Okay, so don't mind this session being recorded. I want to watch this later on to give you more precise working. And I might use that for teaching purposes. Is that okay?
Yeah.
All right. So I used that one before. That is going forward. That one coming backward. Just you try to walk, talk here. One, you're close to that one to record your voice. And yeah, that's yours. And
What? Can I test it?
yeah, test it. So if you need a laser, the top one is the laser pointer, the top one. No, the red.
Oh, this one.
Yeah, this is laser pointer.
points,
Yeah.
right.
And
And
yeah, this
This
is
is supposed
going
to be on.
forward. Yep. Just point it toward that. I think we have to go to
I think it's
the
presentation mode.
presentation mode. Yeah, let's go to the presentation mode.
Maybe I'm looking at drawers.
All right, you want to try?
That's how I do it. Yeah.
The receiver is here. Maybe you want to point it to this one. Yes, that's great.
Oh, okay.
Okay, good afternoon, everyone. Noah, Kai, and everyone. All right. Thanks for coming to this first presentation session. Today we have two presentations. One of them has been postponed to tomorrow, that of the Noah, given that he is only presenter. Yep, so we have plenty of time. It would be roughly about 15 minutes per presentation, followed by the questions. Feel free to ask questions, and I provide feedback. So the feedbacks are not specifically directed at the audience, so these are very general. You interpret how does this apply to your case, okay? So first presentation, I invite Alex and Daniel. So would you start your presentation? Okay, thank you.
1 second.
Could you close the
Okay, so we did a biogas plant to generate gas from fruit and vegetable waste.
So the aim of the biogas plant is to efficiently convert fruit and vegetables into fruit and vegetable waste into biogas that can then be used to produce energy, while reducing the amount of organic waste that is going to landfill. The facility will use the anaerobic fermentation to produce biogas from waste, which can then be used to produce electricity heat for transport fuel. By producing renewable energy from waste, the plan is to promote sustainable development and environmental protection.
Yeah. So for the justification, biogas
Can I
plant
stop ask you a question as you speak? So
Sure.
is this for industrial scale or that's for domestic?
It's for rural towns, so like
Rural.
domestic, but we want either like to a large scale to cover a big rural town, or like it can also be small as well.
So this prototype you're presenting, that's for the household usage, right? The scale of the users.
We kind of did
How big is it?
at least 50 cubic meters.
You reckon that that's for
So,
one household
no,
or that that's larger?
Definitely larger.
Larger. Okay,
Yeah,
go on.
like a small town. Yeah. So the biogas plant will address the issues in rural communities regarding access to reliable energy. Since moving resources to build accommodation and infrastructure is very important, but it's very costly as these communities are far from each other, and they're often located in places that are very hard to get to by transport, mainly desert. So in order for these communities to self-rely on themselves, they need energy, and this can help them out.
So the biogas plant is designed to produce gas from fruit and vegetable waste, serving as an innovative solution to growing concerns about waste management and sustainable energy production. The plant will be able to process various organic wastes such as food waste, agricultural residue, and green waste, and turn them into biogas through anaerobic digestion. The biogas produced can be used for various purposes such as cooking, heating, electricity, and whatever else you need for energy. This project requires a fully functional biogas plant designed to produce large volumes of fruit and vegetable waste daily. The plant must be able to effectively process waste and produce high purity biogas. Safety and environmental considerations must also be considered in the design and ensure the plant operates with minimal emissions and minimal risks. The biogas plant must be equipped with a reliable and efficient biogas purification system to make sure that compliance produce to ensure compliance of produce biogas with the established quality standards. The plant must also have a gas storage system that can store biogas until it is ready to use. In addition, the factory should have a control system that allows remote monitoring and control over the process. In general, biogas plants that produce gas from fruit and vegetable waste are an excellent solution for sustainable waste management and energy production. It is environmentally friendly and cost-effective solution that can make a significant contribution and reduce greenhouse gases.
So for this scope, assumptions, the first one is the availability of organic waste. So it is assumed that a constant supply of organic waste is available to the facility. Any change in waste supply can affect the plant performance and biogas production. Waste consumption provides a uniform composition of organic waste, including fruit and vegetable waste. Any change in the composition of the waste can affect the performance of the plant and the production of biogas. With the composition of biogas, the biogas produced is assumed to have the same composition and quality with a minimum methane content of 60%. Any change in biogas composition may affect the end user's ability to use the biogas efficiently. For the site requirements, it's assumed that the site chosen for the construction to meet all the necessary requirements, including proximity to waste suppliers and end users, as well as suitable soil conditions for the construction of the bioreactors. For operation and maintenance, it is assumed that the end user will be able to operate and maintain the equipment efficiently with appropriate training and support from the project team. These assumptions were critical to the success of the project, and the project team had to monitor and address any uncertainties or changes that might affect the operation of the plant. Other constraints.
Constraints, in accordance with existing facilities, the design facility must be compatible with any existing waste collection infrastructure that already exists. And it will give the organic waste to the facility. This can limit the size and location of the object. So, safety standards. The premises must be designed and constructed in accordance with all relevant safety standards and regulations. This includes safety features such as gas leak detection systems and emergency stop procedures. Projects must be completed within a particular budget. This can limit the size, capability, or quality of the materials that are used for making the plant. The site limitation facility must be in a suitable location that is accessible to your waste suppliers and eventually the users. The room should be large enough to accommodate plant components and all necessary infrastructure. And the deadline, the construction of the facility must be completed with 6 months from the project start line. This can limit the size and complexity of the facility as well as the construction schedule. These constraints were essential to ensure that the project was completed within the approved budget and time frame, while meeting safety and site requirements. The project had to work within these constraints to ensure a high quality and efficient biogas plant.
For the acceptance criteria, the facility must be able to process at least 5 tons of organic waste per day. The biogas produced must contain at least 60% methane and less than 40% carbon dioxide. It must have a purification system capable of removing impurities such as hard hydrogen sulfide and moisture from the biogas to produce high purity gas. The facility must be able to store biogas in storage tanks with a capacity of at least 50 cubic meters. The factory should have a control system that allows remote monitoring and control of the process. The project must be completed within the approved budget and at no extra cost, and must comply with all relevant safety and environmental regulations. The equipment must also be commissioned fully operational 6 months to ensure that the deliverables meet the required standards for the purpose.
The biogas plant designed to produce gas from fruit and vegetable waste
will have several deliverables. First, the plant itself becomes a tangible product capable of reducing organic waste and capable of processing organic waste and producing biogas. The plant will consist of several components, such as an fermentation tank, a biogas purification system, a gas storage system, and a control system. Second, the plant produces biogas as a service. The biogas produced can be used for various purposes such as cooking, heating, electricity, and all the rest. This will provide an environmentally friendly and cost-effective source of energy for the surrounding community. Ultimately, the project will deliver results in the form of sustainable waste management and energy production. Biogas should help reduce the amount of organic waste sent to landfill, reduce greenhouse gas emissions, and promote a circular economy. The project will also promote the production of renewable energy, reduce dependence on fossil fuels, and support sustainable development. So overall, the project will generate tangible and intangible results with significant environmental and social benefits.
The project exclusion, the program does not include organic waste collection or transportation to the plant. Waste is assumed to be supplied by external parties. The project does not include the construction of pipelines or extra transmission lines to transport biogas to the end users. The end user must arrange this individually. The project does not involve the production of any byproduct, fertilizers from digested organic waste. The focus of the project is exclusively on biogas production. The project does not include any changes or improvements to the facility after the initial commissioning phase. Any upgrades must be made individually applied to the end user. These project exceptions are essential to ensure that the scope of the project is clearly defined and that the project team and end users all have a clear understanding of what is and what is not included in the project.
So team communication methods, for the most part we use the big blue button feature, which was within some of the infrastructure website and all that, right? But we did also, we were able to communicate like through text messages, and we did also meet up and all that. So we were able to communicate in response.
Yeah. This was one of our meetings. We've had, I think, 3.
Yeah. Biogas competitors concepts. So this is made by Sandy Burrow. We incorporated the slurry design and tubing plans into our design. Got rid of the
For the needs analysis, first need efficiency in gas production, very high importance. Specifications, capacity has to be capable of processing large amounts of waste for efficient production. Anaerobic fermentation process designed for maximum gas production and gas storage capacity, sufficient gas storage capacity to ensure continuous gas supply.
Waste management is a full priority. So waste disposal system designed for efficient waste disposal and storage before delivery and delivery of waste. And relationship needs to and specification for comply are directly related to these specifications, contribute to the effective management of waste.
For safety, high importance as well. There will be a gas monitoring system, where you're monitoring the gas levels to prevent explosions, an emergency stop system. In the event of an emergency, the system must be able to shut down quickly, and protective equipment for the operators.
What is Marzine's control
Systems.
in the last
Yeah.
row? Marzine control system, what's that?
It reduces the effects of plants in the environment that it has on the biogas reactor.
Okay.
And then there's a part 2. On reliability.
So you see the cost effectiveness, the low cost of raw materials, like, yeah, we want to use, I guess, low cost raw materials for the other parts we have to create and all that, right? The excessive use of energy optimize the use of energy for the cost reduction, and when making this cost, the factory must be, within the facility, it will have to be designed such that it won't require too much maintenance. So, that's how.
Yeah. For reliability, importance, it must have a durable design that should be designed to withstand wear and tear, reserve power to ensure continuous operation of the equipment, and a regular maintenance schedule to prevent breakdowns. Regulatory compliance, also high importance. You would need permits and licenses to operate the facility, of course, and safety compliance and environmental. So our authorities in waste disposal just need to comply with the waste disposal regulations. Scalability.
Scalability is the medium life. So modular design factory components should be designed to be easily extended and expanded if needed. Adequate infrastructure should provide adequate infrastructure for future expansion. Design for future growth. Design the plant to essentially accommodate any future growth or whatever if it is necessary. So need a specification between related specifications which contribute to ensuring the scalability of the plant. Training schools is medium priority. Is the training program we have to develop this will be a training program for for equipment operators. We'll have to have skills skills and qualifications required for the operators and all that.
This is a mind map. Part of the video. So we just ask them questions and some answers. So, for example, what's optimal mix of fruit and vegetable waste and product production, which would obviously depend on the waste composition and diversity design, which we went for a circular one with no legs, so it kind of sit on the ground. And the importance of site climate safety standards, both strands, as said before. Site requirements for the biogas plant. I guess.
Other site requirements may include access to waste suppliers and end users, suitable soil conditions for the construction and adequate space for plant components.
Yeah.
That's what I guess you have in the biogas. It should be optimized for effective end user use.
So the biogas composition can be optimized through the selection of specific bacteria strains, temperature and pH control. And efficient biogas storage and transport systems will also help with that.
Okay, so what are the necessary operation and maintenance procedures for a biogas plant? So operation and maintenance procedures may include regular monitoring of the distributed conditions, biogas quality control, and staff training. So the certification of feedstock. Fruit and vegetable waste, such as peeled pulp and seeds, with a moisture content of 80 to 90%, and a C/N ratio of 25 to 30. Digestive pipe, a continuous stir tank reactor, or CSTR.
And the volume must be 500,000 cubic meters, depending on the feedstock and design gas production. Taking 25 to 35 days to ensure adequate digestion and gas reduced.
So operating temperature is 35 to 40 degrees Celsius to optimize the activity of bacteria. Continuous mixing by mechanical stirrers or recirculation pumps to maintain homogeneity and prevent solid setting.
Yeah. For the gas storage, the storage tank must have a capacity of 2 to 3 times the daily gas production to allow for fluctuations gas demand and production. The composition is above 65% methane, 30 to 40 carbon, and trace amounts of other gases such as hydrogen sulfide and nitrogen. Utilization.
So gas utilization combustion in a generator or boiler to produce electricity or heat, or injecting the natural gas grid after upgrading to remove impurities. Separation of just liquid and solid fractions. We did liquid fraction used as the fertilizer and solid fraction first were used as animal feed.
I'll move on to the update. As you can see, there's the lowest important is 3 out of 5, so this is very important. And there's here very few weak relationships, but mostly moderate to strong. For the competitors, the main one was the third one, the best design. But so the metro to incorporate materials like the same
So concept one, this is so pretty I suppose you basic concept that it's not something like right. So it has this types of right where I guess you have I guess the waste and it have an exit pipe for when the gases so out the line right.
Yeah, there's a tube that connects the tank inlet into the slurry slash main digester.
So this is concept 2. So this one is I suppose a little different from the other ones. So this one I guess will be more around like have a mixer. The exit pipe is and
It's like on the inside, so you can open the lid with the on-off valve closing at the bottom. This one has legs though, so it would be more
What do you mean by on-off?
The
Valve?
yeah, it's like a screw, like a tap.
Okay. So that's for drain.
Yeah.
That's for when you want to drain, want to empty. Is that what it is?
Yeah. But this has legs, so it's slightly less cost efficient if we're trying to build more. Third one.
the third one is here has the outlet on the top there. It connects to the center, which is the digester. This one also has legs and the on-off valve at the bottom.
This is like a combination of the first and second, have the outlets at the top and have the drain lines at the bottom, and it's got the legs for the second one. We decided to go with the first one as it's the simplest and most cost efficient way. But if you use task efficient, it can be hand operated, although you could install a mechanism on the inside. And it's cheaper due to having no legs, meaning it can be more widespread across many rural communities instead of just.
Showing you the interior.
Yeah. This was our Gantt chart. Shows the process of really at this point. Pretty simple, really. And then after that, thanks for listening.
Okay. Thank you for your presentation. Question to the audience? Any questions you want to clear? On your question,
How much does it cost?
It's supposed to, yeah, it's supposed to be a good one, so I mean, it would depend on like, right, on like a fixed number of things, like, right, there is also, I mean, I guess the cost of producing the biogas kind of itself, right, but then I guess you would also have to take into account, I guess, the operational costs and all that over time. So it could, I guess, vary depending on how you sort of contract that.
Yeah.
okay, any other question? Yeah. All right, I have some questions. Right. Thank you for the nice job you did. And well, a presentation, well, few generic comments that applies to every presentation. You want the text to be readable by the audience, so perhaps the font size is very critical. So I doubt if people sitting in, I have difficulty reading some of the software too small. And when you are doing an oral presentation, it is expected that the minimal amount of the content is appearing on the screen, and everything else people expect to hear from you. So there are two extreme cases of people who do the presentation, right? So one extreme is people are overconfident, no matter what they are presenting, they just oversell it, and you feel that they have done something really great, but nothing is there. The other extreme is you are very modest, too modest with respect to what you have done. Okay, it's always best to be in between. So some general thing is anyone knows what read it loud. You know there's a function in some of the applications that is called read it loud. So it used to be, I mean, it has been an option in Adobe Acrobat. So you load the document, and sometimes you are driving, you want to sleep something, you want someone to read that document for you. And once you invoke that function, you can choose the voice of the narrator to do someone who is reading for you, male, female, and then you start fast, slow. They just manage as long as the text they can read it from you. So this is largely not encouraged because the minute you start to read from your note, whether that's a cheat sheet or you're reading from your laptop, so people are sitting, I mean, first of all, there's some jobs can be taken by computer. Computer can do them better than us, right? They do it smoother, they're making more entertaining, all that. But apart from that, audience would lose interest to what you're saying. They try to read it from the screen, and guess what? They're faster than you. You're nervous, you're studying there, you just don't feel very well, but people are relaxed and having a popcorn, watching your presentation. They can read it much faster than you. So immediately it becomes something they neither read it from there nor listening to you, and then that becomes less engaging. So that's not directed to your presentation, to every presentation. So when it comes to the when it comes to yes, here the text you see they are small, and the scope description I expected like needs. I expected to have bullet item summary that is much easier, more concise. And then you know what? When you make this bullet item, it's best to make that something verifiable. What do I mean by something verifiable? That is meant to be a checklist. Your client is going to tick, say, okay, first one tick, second one tick, and then we're happy with that. It takes a big deal to prepare that need list to include a number of measurable things. So as long as you talk about something qualitative, well, that's too subjective, all right? People might disagree with you. You say something is durable, and they say, how durable is durable? How do I know that this is durable, all right? But the minute you put some numbers on it, that becomes totally different things. So I urge everyone with your presentation, with your final report, which is next week, make sure you go through the checklist and make sure you're touching at least all of the checklist items. Some of them maybe you can write more, some of them you can write less, but it's best to address all of them. So something which I expected to see here was the choice of the material, right? The size, the capacity, and the bounding box, what space is allocated for that one, right? Temperature control, what kind of environment is this being used in? This is for a humid environment, this is for a hot environment, for cold environment. So these kind of things are making your design different with someone else's. And you see this scope, bullet item, smaller, something measurable, something verifiable. These are more preferred. So communication methods, yes, big blue buttons. I had a fight with IT department regarding big blue button, and you know what? People who don't care, they never get the blame. For that fight, I'm being blamed by my manager. Why you been so harsh to the IT? And then, yes, this is a tool. We are paying for it. We are supposed to use it, but that was not very useful. As long as the recording either did not happen or they disappeared too quickly. Yeah. So my manager preferred to just take the easy part, say, why did you be so harsh, rather than saying, look, we need a tool to give the students to do their job. Anyway, so with the minutes of meeting, it's good to give a good statistic to say, look, we had one meeting, we had two meetings, we had 10-minute meeting, something like that. These were the agenda, these were the decision taken. So that's what we expect to see from the minutes of meeting. When you are putting something like here, again, need list, none of these things are measurable. Safety, waste management, so these are high, low, medium. How these are going to be verified, right? And mind map, I want everyone, I mean, apart from this unit, get used to using mind map as a very useful tool for planning your ideas. And then you can do that best when you are using the professional software. This mind map is not generated inside. I can imagine how much time you spend in generating something like that. But believe me, if you try something professional like FreePlane, mind map, there are heaps of such software that are free. You can use them. And for organizing your daily work or your university, everything, mind map is a great tool. And then it has to be multi-layer. It doesn't matter how you organize them. You can add as many balloons as you want, and this is dynamic. Always you can retract, explode, and then just get something very professional there. With the specification table, we want to see the correlation between the specification and the needs. And here, texts are too small, that's okay. But at the top here, we have the interaction of the features together, right? Some of these, they're interacting together. So here, this is the room you show how do they interact. And bill of material, I was expecting to see them. Unfortunately, that was not here. And when you are including some illustration, it's okay to take them from a patent, but make sure you include the patent number wherever it's been taken from. Is it professional? And in case if someone wants to pursue your work, they have a reference, we go and get it from there with more detail and then reading that. So this one was not very informative. I struggled to understand how this one is. Yes, and I'm going reverse. Yeah. Okay, this one. Okay, I expected to see some kind of calculation to give them a score, and then how did you justify the choice of one concept compared to the others? The animation was great. I assume that this 3D modeling was your work, right? Or did you take it from somewhere else?
No,
You did it yourself. Okay, you deserve a very good credit for that. That's a good job. But yeah, something like choice of material, choice of manufacturing, whether you find something usable for repair press. That was the main idea. I mean, here your client are people who cannot spend money as such, so they prefer to find something which is useless and they bring it back to life. So that kind of initiative, this was, yes. And apart from that, your Gantt chart, that is for everyone. I expected to see the 7 steps of the design as the main task, and every task has a sub-task. So here, details are missing, and I expected to see the 7 steps of the design here because they are showing the sequential order of things happening from the beginning to the end. And that, if you're writing your report, I suggest using that title and then adding more detail to this one. And again, thanks very much for your presentation. And please join me in. Thank you, Alex. Thank you, Daniel. All right, the next presentation is by. Let me get this one. All right, beautiful.
Good evening, guys. Today I'm here to present to the innovation and sustainable solution that's a free gas at home, totally biogas system. Uh, why biogases we need to the our life? That's a totally it's a renewable energy. It's a renewable energy source because they are product from organic materials that can be continuously replenished. And second one is waste management. Waste management means it's a biogases play a critical role in effective waste management. It's an organic waste such as agricultural residues, food scraps, and animal meat can be transformed into the biogas through. Uh, this is my need analysis. This is a two parts of need analysis. This first one is environment. It's a my products have a pH value should be between 6.6 to 7.5, and emission temperature must be controlled, and nutrient content of raw materials product. And sorry, and second one is product quality. That's a reduce maintain costs and affordable for everyone, and can keep on your balcony or backyard from your home. There's a no need to heavyweight installation work. That's a my need analysis. This is a governmental and law limitations. The I think that's a 2004 Act. That's a petroleum and gas limitation rule. This is a patent have the Europe company uh, that's a 1995 to 2021 this field related to the biogas production. That's European patent office. So this is my mind maps. First of all, I am a portable biogas unit. The this is a advantages. This is advantages and resources and materials. This is a materials have a lot of durability, safety, and resources have a. I got the Google patents, Google Scholar, research articles, and Australian government websites. That's next part. This is my Gantt chart. This is my date, the selection of the project of the understanding project. Next part is project planning. This is the introduction and research. So background, so it's called mind map analysis of needs. And third one is project development. It's a cost analysis and drawings and everything. It's the government's rule and regulations. That's the last one is presentation of my final project. So slide preparation and final project and feedback. This is my specification table. That's a this is my funnel. This is my materials. It's a UPVC pipe. It's a tank nipples, tank. It's a couple. It's a elbow. There's a lot of that's kind of things I'm using in my project.
That's bill of material.
Yes, yes, yes. So, this is a house of quantity analysis. Uh, this is my man. This is a affordable price for the our customer or client. That's the main thing I'm focusing for that project. This is my first concept. This is my first design concept and second design concept. The the first one is the this is a bio tank in here, and that's a second one is the it's a underground bio tank. Then that's two concept. I'm based on my final concept. This is my final concept. This is a what are the unique things is this concept. This is a fully eco-friendly product. This is a because the main thing is the solar panel is the fully powered by that product. This is my machine operation process. The that's a kitchen and other carbon waste are put on the hopper of the machines. Uh, my hopper in here. Then kitchen waste is cut into the small pieces by a cutting mechanism, and it's a put in the my hopper. And it's the third one is in the suspended. This is tanks happening the microbial activities and gas storage in the working gas storage tank. That's my gas storage tank. While doing the microbial process, gas generation also happens. The gas is going to the kitchen biogas cooker. Uh, that's my kitchen biogas cooker. That's a output. That's a outway to the gas system. This is control valve. We can control our gas pressure, gas temperature. The mechanic has around the small controlling unit to control the condition of motor and valves and heater and fan. Okay. That's my bill of materials. So, over base grinding motor, turning wheels, disaster removal valve, the wheel gas storage and suspended digester tank, controller box, pipelines. This is my work breakdown structure. That's the main things. The identify the problem, and second thing is the project planning, and third one is project development, and fourth one is project presentations and project reports. That's my according summary. So that's a material and manufacture and transport and use and disposal. That's my product have a main innovative part in the I am using the solar power methods. The method is constructed with a fully automate the machine with solar energy. blue construction are best options for the method construction. The method was converted to the machine. Yeah.
It's very important. All right, thank you, Sultan. Now, question from the students, please. Okay, so give me that one, please. While you're thinking, I have some questions. Um, all right. So, starting from the beginning, that was reasonably good work, given that none of your team members were engaged. I noticed that you did that by yourself, and that is appreciated. So, yes, the quality of the slide, they are quite readable. You started with the significance that has how every presentation should start. That is the most important part of the presentation. You have just some time to get the attention of the audience. If the start is not catchy, is that is not attractive enough, maybe people decide not to listen to it. So a very good start is telling people why you are doing this, why this is important. Give them some background information. That you can easily access some commonly available statistics. The statistics are eye-opener. People would be surprised to see the numbers. They don't know how much money they pay for example, fuel in rural community, what are their problems. If you put some statistics, that makes this really catchy. And okay, so that's a good start. And when you went into the need analysis, some of your items are quite well measurable, like pH, but ambient temperature one must be controlled. That is good, but you could be specific. Um, Reduce maintenance costs. So all these things is not easy to agree with someone. Maybe the way you want to conclude that is different with someone else. If you make something concrete with numbers, measurable, verifiable, that is good. So that's very interesting part of your work. That is the responsibility of the designer to look for the regulation, restriction, limitation. And I want every presentation, every report, you just show. I'm not saying that don't miss a document, don't miss a standard. That's very difficult. You never know how many standards are there, how many regulations are there. But in real life, if you miss a regulation, a standard, what happens? You spend some time, you invest on something, and then you're not authorized to do that because that's against the law. That's the first thing you want to check. That would be too bad. But for this subject, I want you to show an awareness. Just show me, look, I care about the limitation, I care about the regulation, and that I think you demonstrated that quite well. Um, yes, that patent, I mean, you included a number of illustration. Every patent comes with some illustration, tell them how these things is. And mind map, again, that was a good one, but I strongly suggest everyone, please try to use the professional mind map software. These kind of mind map, this is torturing yourself. That tool is not made for making mind map. So a mind map professional software is easy to work, is efficient, that can be added more detail. So here, if you want to add more detail, there's no room in this space. But in a mind map software, you can add as many images, link, hyperlink, everything, and you can do an ongoing job on that one. So I see that you have started from week 7. That's a realistic thing, but because I only told you about the project management, project control in nearly week 5, 6, but before that, I tried to do that for you. So all the weekly submission, they're part of the project plan. Maybe you didn't plan them, but if you would, that would have been the same steps because every design should go through the sequential, logical order. You start with the customer negotiation, understanding the problem, finalizing the need, finalizing the specification, bringing the concept, freezing the concept, going to the detailed design. So those kind of things, please, when you are making the Gantt chart, use that 7 steps sequentially here, and then add detailed step to those. So when I'm gathering the concept. What are the steps? What are the subtasks? So include them there. When did you do it? Who did it? What resources did you know for that? These are the typical things which go to the Gantt chart. And I noticed that you included a specification table. How do they relate to the need? You have to demonstrate which specification links to which need. That is not quite complete. I wanted to see the interaction, so these numbers have to be identical to your need list, to your specification. Two concepts you presented that is quite good. And how did you generate that illustration? Is that your work or you got it from somewhere else?
This is my work.
And which environment did you create this in? What software?
Oh, I'm doing the photo editing software.
Okay. And no 3D modeling. You didn't do any 3D modeling, right? Okay. All right. So you notice that with computer-aided design, that is, we can afford not to use them, right? For something serious like this one, when you are referring to the control, Arduino is something good for programming, but I'd rather to have something simple but complete rather than something comprehensive but not detailed enough. Okay, so yeah, that explains your detailed design well, how the subsystems are working together. And operation, you went through the explanation, that's good, bill of material, eco audit, work breakdown structure, these are deliverable items for every project you want to have them. And eco audit, yep, that is you're using solar panel for operating the system. That is a good step. And yes, altogether, given that you worked on your own, I'm happy with your performance. Question from audience? If no question, please join me in giving a All right, so you're going to do the presentation. Have you uploaded that in your Canvas group? Go to your group, copy your PowerPoint, you know, Alex, could you help me to do that, please? Yes. Which group number are you, Mohammed? 12. G12. G12. Yes. While we are waiting for the upload, anyone here received the invitation for the free lunch? Have you accepted it? Or
I denied it.
you denied it? That's good, better than
At least he knows.
unanswering it.
Yeah, this class doesn't have any classes on Thursday.
All right. So my point is, I need to know whether you come or not.
Yeah.
I can be on limbo. What about you? You're coming for Thursday lunch? Free pizza? Are you coming for ceremony? Yeah, go on.
I saw that it shared that in line for that.
That's nearly the lunch time. Before 12.
Okay.
Near 12. Yeah, I emailed you the invitation. You received the invitation. So is this copy there?
Yeah, if you use software.
let me see PowerPoint video. Just a PowerPoint file.
Just out, I made it on PowerPoint.
Oh, yes, presentation.
Just but where this is coming out here, there is what
Molly, you're from yes, this one's okay. On that side. And, yeah. All right, so the last presentation we have for today, that is presented by Mohammed Hassan Malik. And please, you will be using that one to go forward. This is the laser pointer.
This one to back and this one
No, this is to forward, this is to back. Forward, backward, laser.
forward, backward.
Okay, let's get a start. Go on.
First of all, here it is a mind map. I started from mind map, like the free gas at home. My project is free gas at home, and first of all, it is the types of gases, biogas production at home, and then it is like advantages and disadvantages of free gas, and like they are like advantages like cost savings, technical challenges, environmental benefits, and like that. And after that, there is like after that we go there the gas leak detection and prevention. It is of safety consideration. It comes in safety consideration. The proper ventilation, air quality monitoring. After it is about rules. It is about regulatory considerations. Like we have to get the permits and approvals, compliance with the local laws. We have to look about the local laws and regulations. And at the end, when it is finishing, it is like we have to see the future of free gas at home. Like we have to see the future of this project at home. So it is telling us like the emerging technologies and advancements potential for wider adoption. It can be for wider potential impact on energy consumption sensitivity. It is a justification of the scope. It is all the it is now it is a part of the scope. Here we define the scope of this project. It is a justification. It is the product scope description. This one is the acceptance criteria of this project. Like here, I have given some information over here. In order for the project to be accepted, there are some criteria it must be adhered to. Like it must be for safety, production must be safe, and these types of things. Furthermore, as it is will be producing a flammable gas, the drum must be secure to prevent any unwanted ignition and must be effective, and the output must be able to provide a sufficient amount of energy in order for the project to be considered profitable for the users. Because at the end we have to see the profit and the efficiency and the output we are getting. And after that we are talking about the deliverables, project experience. This method is currently for pig manure and may not be suitable for others such as cow dung or horse manure. Although it is named as free gas source, that does not one wish to have free access to the manure will have to purchase it. Here we are talking about the constraints. And at the end of this, and when we are defining the scope of the free gas at home, at the end it is assumptions. This is the last part of the scope of free gas at home project, and it is assumptions. Like the assumptions must be made. Like will need to be assumptions made as to know how many people are able to use the project as a key integrated SP manure. The system can only be useful for those who have access to the manure as assumption. Will therefore need to meet for the demand. This can be made by considering the number of pig farms in the area, looking at the average amount of manure produced in kg. and the energy consumption of site by running tests on the production method to see how much energy is produced per kg of pig manure. It is possible to see how much energy can be produced per site based on its manure supply. It will be therefore be possible to analyze if the energy produced will be beneficial to the consumers or not. And after that, here comes a Gantt chart. The first it is identifying the problem, then it is the project planning, after it is the project development, then it is project presentation of the final project. In identifying it comes a selection, understanding. In planning it comes an introduction, review, referring, scope, mind map, analysis and material selection. And in the third one, the project development, here it comes the analysis of cost, deploying and designing, referring, government rules, introduction of final product, project, and in the fourth one, project presentation of the final project, site preparation, presentation of final project and feedback, and at the end it comes the project presentation. Needs analysis. Each should be between 6 to the requirements, the purpose. It should be between 6.6 to 7.5. Ambient temperature must be controlled. Durability, sealability, compatibility, lightweight, surface mount should be cost effective, small in size, and it would be purpose and affordable for everyone. There is no heavyweight installation work can move, keeping your balcony or backyard. It is efficient. It is the design embodiment. Like here, it is a bucket, 30-liter bucket, and this tipple is made for ventilation. 75% of waste and 25% of water. It has like the total covered area includes 75% of waste and 25% of water. And it is the things used in like 1% inch clamp, diffuse pipe plug elbow, and then a TA plug tank nipple elbow. And it is a patent. It is the first patent. This one. And it is the second patent, and it is about the central heating system. This one. This is a patent of central heating system. And this one is the third patent. The patent describes a system for converting biomass into a syngas through a process of partial. The power pallet is designed to be compact, portable, and easy to use, making it a versatile solution for a variety of applications. This is a specification table. 40 liter of plastic water drum is needed. 30 liter and 20 liter water bucket, 1 inch elbow, 1 inch ball valve, and like that, all the things in the utilization. It tells like, sir, what is the purpose? Sir, as a digester and gas holder, and the number of units. It is all given here. Like 1 inch clamp is used to fit around the pipe. Copper ball valve is used for gas application. 2-meter gas pipe is used for gas transportation. Bill of materials. It is a bill of material for simple design to make gas tank, pipe, and valves. Gas tank. A 20-pound propane tank can be used as a gas storage tank. Gas pipe. A pipe that connects the gas outlet of the gas tank to control valve. Control valve, a valve that regulates the flow of gas from the gas tank to the stove. Pressure regulator, a device that regulates the pressure of the gas flowing from the gas tank to the stove. Connectors and fittings. Various connectors and fittings are required to join the pipes and valves together. Stove. A gas stove is required to burn the gas produced by the gasifier. Overall, the BOM for this simple design will include the gas tank, the gas pipe, and the control valve. The pressure regulator, connectors, and fittings, and the stove. The exact component and quantities required will depend on the specific design and design of the system. It is the bill of materials, like product, 40-liter tank, price, number of units, supply for all is the same, but the price is different, the number of units is different. Like half-inch clamp is for $8, and it is 2 are needed, and the supply is the bunny. Now it is a work breakdown structure. like identifying the problem. For identifying the problem, the first 1.1 task, selection of the project title, understanding the project, and after that, when we have identified the problem, then the second step is that we have to plan, project planning. In project planning, at the first it comes introduction and research background, literature review, analysis of need, materials of selections, and when we go to the third part it comes cost analysis, drawing and design, and the third part of it is referring government rules and regulations. The fourth part it is slides preparation. The 4.2 is final project presentation and feedback. These four are the parts of it. This one is the at the end it is the cost and risk analysis. Cost analysis, gas tank, gasifier, materials, fuel source, cost analysis. Uh, the cost of making free gas at home depends on the several factors, including the size of the gas tank, the cost of the materials, and the availability of organic waste and other fuel sources. Here are some of the cost factors to consider. Gas tank. A gas tank is required to store the gas produced by the gasifier. The cost of the tank will depend on its size and capacity. A typical 20-pound propane tank can cost around $40 to $50. Gasifier, the cost of gasifier can vary widely depending on the size and complexity of the system. A basic gasifier can cost anywhere from few $100 to several $1,000. Materials and other materials required to build the gasifier, such as pipes, wheels, and fitting, will also add to the cost. Fuel source, the cost of the organic weight or the and the fuel source will vary depending on the availability and local prices. As we have used pig manure here, so this will only organic waste we use. After that comes the risk analysis. This here in this part it tells all the risks affiliated with this project, like all the risks which can be affiliated with this project, like fire and explosion, health risk, maintenance, legal and regulatory. Like previously I told about the rules, local rules. So here it is telling the while making the free gas at home can be a sustainable and cost-effective option. It also comes with some potential risks and challenges that should be carefully considered before starting the process. There are some of the potential risks to the consider. Fire and explosion. One of the most important risks is to like we have to prevent the depositors of gas. So we have to focus on fire and explosion. It is the biggest and the first gas produced by a gasifier can be highly flammable and explosive if not handled properly. Careful attention should be paid to the safety precautions such as ensuring adequate ventilation, avoiding leaks, and using flame arresters for other safety devices. Health risk. The second biggest risk is the health risk. Gasifiers can produce harmful emissions. These emissions can be harmful such as carbon monoxide, which is one of the biggest, and other pollutants if not properly designed and operated. Proper ventilation and air quality monitoring are essential to minimize health risk. Maintenance. Gasifiers require regular maintenance and training to operate efficiently and safely. This can be time consuming and may require specialized knowledge or skill. Legal reliability issues. Depending on the local laws and regulations, making free gas at home may require permits and other approvals, and there may be restrictions for use or storage of gas. And at the end, I can say that we have to focus on local rules and regulations because rules are first, and we have to get the permits and approvals. And at the end, it ends about that while making free gas at home can be cost effective and a sustainable option, it is important to carefully consider the potential risks and challenges before embarking on the process. Some sure here are some hypothetical prices for the components involved in making free gas at home using a gas tank, stove, gas pipe, and rails. The gas tank is given gasifier, and for materials, other materials required to build the gasifier, such as pipes, base, fittings, will add to the cost. Let's assume a total of $2 for these materials. Fuel source, the cost of the organic waste or fuel source will vary depending on the availability and local prices. Let's assume a hypothetical cost of $50 per month for fuel, just for fuel. Like we are using a waste which is $50 pig manure. And at the end, here comes a total cost. And at the end, here comes the total cost. So the total cost at the end it tells like all the cost, and so the total cost will set up and operate the gasifier to make the gas at home. initial investment. The initial investment will be like around, this is not the exact one you can say, but it is around $1,240 gas tank plus gasifier and materials. This is the initial investment like which I have assumed. This can be, your can be different. Monthly operating cost $50 fuel, which when this pig manual, the cost which is being used, it is important to note that these are hypothetical prices and actual cost may vary depending on the factors such as local location, availability and materials and the specific type of the gasifier. Additionally, as I mentioned in the previous answer, there are also potential risk and challenges associated with making free gas at home that should be carefully considered before starting the process.
Is that it? Question from audience?
So is that cost for one person or is that for a group of people?
No, it is for the project. Like, it can be different for you. It is an assumption made by me. Like, for you, it can be different. For Siva, it can be different. But for myself, like, it is not fixed. Like, it is flexible. It is made by me. If you made this, it can be different. It can be different for like everyone. But it is like just around.
Okay. No more question. I have few. Okay. Hassan, I noticed that you did this project by yourself. You were a part of a team. So failing to work in a teamwork is not, good sign. This subject of the unit learning outcome is, I know that this is difficult for some of us. This is the first time we try to reach other people. Maybe they are not in the same class, but believe me, by doing this, that's the only way we learn how to socialize, how to get the work, and that's what you will be expected in future work. Okay, so again, my main comment, we expected to see some product, and that didn't happen. So this is like you invite someone for dinner, for lunch, and you tell them nice stories about delicious food and everything. You get them hungry, and then at the end, you don't serve them with the food. So that um, I expected to see some demonstration of what we discussed in the lecture, what we discussed in the computer lab. Some of these are related, but look, I still wait to see your final report. So that I'm not quite happy with what you presented here. Some key elements like 3D modeling are missing. So the good thing, again, mind map, you have to use the professional tool making the mind map. So the contents are somehow organized. Using the mind map lets you to add more layers, more detail, useful into this one. And people are always afraid of, I'm going to use my job, I'm going to use my job, robots are going to take my role. And you know what? Read it loud is a major threat. So it's not only the Adobe Acrobat will do the reading loud, even all new Microsoft product has that feature. So all you have to do is to load the document, just click a button, and they read through the document for you. All right? So you have to do something. This is I really want to give you something to get you prepared for what you will be facing. That's not going to be easy. All right? So people are doing very great jobs. They are successful in business, but if they don't anticipate the risks, the threats in future, they easily would be out of market. You might have heard that Jenny Craig went bankrupt just 2, 3 days ago. And I remember it was only 15 years ago, 20 years ago, she was a very successful business person running the program for losing weight. Everyone wants it. But if you are not aware of what development is happening around you, this is a big, big risk. You have to do something that robots cannot do, artificial intelligence cannot do, and reading through the slide, believe me, that's not going to secure you a job. Okay, that's a generic note to everyone. I'm not targeting that to Hassan, to everyone. You have to use, all these units was to give you the tool you need. I'm not saying this is enough, but believe me, it makes a big, big difference if you can present the information in a graphical way rather than the verbal way, that's the last thing people want to see. I mean, verbal communication becomes less and less attractive, given that this was just 2 days ago, Google released their lookalike robot for ChatGPT. That's called Brad. Have anyone tried that? I just before coming to class, I was using that to get some statistics, some data, and you'll be amazed to see how good they do the job. So if you don't equip yourself with the technology, the tools, that's going to be a very sad waiting for you. I'm not sure if you can secure some professional job that you deserve. All right, make sure this subject we try to share with you. I mean, I'm not saying that was the state of the art technologies or tools, but just using them, that's better than nothing. All right. So with your presentation, I mean, this is not organized in a way that I wanted you to do in the logical order of a generic project. 7 steps, they are not shown here. And well, I guess that project is a safety and health issue. You can minimize, I'm not saying don't go for it, that was the title of the topic, but how can you make this avoid some of the problems? For example, this one, I don't see any sewage system. So when there are effective periods for using this device, 1 week, 1 month, 6 months, I don't know how long, but eventually you need to empty that and refill it. So people get something like this one is not healthy, and with all these pig manures in it, they have to empty it from the top. Where sewage is a big system. I mean, if that's used in an agricultural system, I mean, maybe that can be directed to the agricultural land for the fertilizer, or that's something really, as a designer, you have to be mindful of. Patent, that is good, you choose the number of patents, but I wanted to see more graphics rather than text, something visual communication, something with the exploded view, numbers, for people understand this. I mean, from here, how am I supposed to understand what this thing is? I'm sure in the patent there are enough details, and but your selection doesn't tell me much, and your explanation didn't add to it either. So that's when I hardly can see the number or the subsystem, understand what they do, and or the specification table. Again, my concern is bill of material is not related to an existing product. 3D model, animation, all those graphic things could be here. They are not. All right, I wait for to see your week 12 uh, report, and that can make a big difference. I hope you can address as many as these things, and also the checklist in the announcement I said, make sure to go there and touch everything, show some awareness. I know the topic. I can communicate with what was discussed, what was explained, exemplified, and I can apply this to a generic project. That's all I want. It's not a big request. Don't let me down. All right. All right. Please join me in giving the round of applause. Thank you, everyone, and I appreciate some of you. Your presentation is not today. You came to the presentation. That's a very nice thing to do. It's a respect to your friend, the student, and I think I'll let you go. You can use this time for working your project or doing something. You're getting very close to the end of semester, and every minute counts. All right. Thanks very much, and all the best.
This presentation is like 15